Here we go. So we're going to go through the study set, and again, your study set hopefully is uploaded. And yeah, if you're having power issues, I have somebody in my other class who just send me an email, and so there's some forgiveness there. Hopefully it's all working. So a couple things I'll mention. This is for Tuesday are your class presentations, and you do need a camera for it. And so if you don't have a camera, like Omar and I both have cameras, because there's several of you, I don't know who you are, and you obviously need the ability to talk. I would ask that you stay after today for 5 minutes and talk to me so we can figure this out. I've always been able to figure it out for students, but yeah, I realized some of you are still shy of me and haven't really communicated yet that. The other thing was a question that Mindy asked about office hours for Saturdays. So I am leaving tomorrow morning and taking the train across the country. And so that's part of why you don't have a lab this weekend, because I didn't think I was going to be available. I go through Washington, D.C. tomorrow, and right now Washington, D.C. is on complete lockdown. And so I will probably be sitting for 3 hours in a hospitality room rather than walking around and seeing all the great monuments. So I'm thinking through my head, I'm doing the time conversion. I think from like 10:30 till 12:30 on Friday, I may actually be available. You can send me an email. This is in the morning, AM. This is 12 noon. So if you have questions, like if you're available then and want to go over your lab, you have to resubmit, or like the worksheet or any of the stuff we've been doing, send me an email and say, hey, are you available? And I'll send you a Zoom link if I am. And the same for Saturday. I'm doing a conversion, sorry. Saturday, it would be similar, and that one would be the Saturday office hour. So you can always go in and see if I'm in there on the Saturday. That would be the regular Saturday link, and send me an email, and I might be available and can open the Zoom link up. My other classes, I told them I'm not, so it would be reserved for you. And so, yeah, Chicago's an interesting place right now for other reasons. So please do that, because you have that lab. Several of you want to redo it, and it can often, with us talking for like Spencer stayed after the last class, and within 5 minutes of us talking through, I can pull up what you had submitted before if you don't understand my comments. You do have till Tuesday to get that in. There might be time on Tuesday with the presentations, like at the end of the presentations, if you have a question on it that you still want to ask. And you can always try sending an email. I might also, Monday is a holiday, so I don't have my other class. And so I might be able to have a Monday office hour. So if you need help on Monday, send me an email and see if I'm available, and also tell me when you would be available. But tomorrow, Friday, it would probably be that time. And you send me an email, or I might send an email to everybody and put the link on our Blackboard page. All right. So with the study set, so Tuesday are your class presentations. Sorry. And just real quick. I'll just put this up here. This was what, I don't know if you guys can find your name on there. They were kind of alphabetical order based on your last name. But you all picked a time sometime by Tuesday, and it actually pretty much works out. So you're either 2 to 4. It is going to be the regular class link for all of these, and just be on time, because part of your grade is being there for the 2 hours and participating. So you will share your screen. We'll have whoever as you volunteer, and you'll do your talk, and then you have to interact with each other and ask each other questions, and you're going to be writing down comments for each other. There is a thing that is posted in the syllabus folder, and then when I open the week 3 folder, it's also there. And you're doing a presentation, and then you're also writing up your presentation. So some people actually do much better in the written part, and some people do better in the presenting. So you are doing both. So there will be a place to upload your paper. And then again, if you have questions, say may have questions. Hopefully you know your element. And if you want to change your element, send me an email. Just always give me 2 choices and I'll tell you if it's good, if we're good to go. Oh, I know the other comment I was just going to make, and I'm actually okay with these numbers. The most popular time was 5 to 7, which is fine. It's 10 people. But if somebody in that group wanted to switch to the 2 to 4, just let me know. That would make them a little bit more even. But my hope is with these presentations, we'll be in a little bit smaller groups, that you'll get to know each other a little bit also. And my other classes are, yeah, people start to get to know each other. On Zoom, it's a little bit awkward, but it can help. And to also have somebody, like you have somebody that you have a study partner with for doing homework and stuff. So you're not so dependent on me. All right, questions 1 and 2 on your study set. And again, I'm not going to apologize, but you have to accept I've always done this where we're live and I can interact talking with you and we get to know each other a little bit better that way. These 2 questions are logic questions. Why I didn't give you a lot of space like I did here to show your factor label. And so the question's asking which one has the most atoms. Now you could solve it, but you didn't have to. You could have just logically been able to think through it. Like looking at gallium, gallium's 69. I'm just going to write the numbers here. Aluminum's 26.98. These are grams per mole from the periodic table. So hopefully you've got that part down, that's what this number means for arsenic, that there's 74.92 grams per mole. And you could write that step down. And then technically next step would be to go to Avogadro's number, but they're all going to end up with the same last step. So there's no real need to go there. Whichever one has the most moles is going to have the most atoms. So Miles, the email you had sent me today, that's what I was, I guess, trying to say. Sometimes it's hard for me typing. It's also hard for me speaking. But if we look, this number is going to be less than 1. That's going to be really small. The arsenic is the only number that's going to come out greater than 1. Again, you can punch them in, but just looking at the ratio, arsenic's going to come out as the largest. So our answer is arsenic. On number 2, we're looking at mass. We're trying to figure out which one has the most grams. And again, it's a logics kind of thing. So for sodium, sodium's basically 23-ish grams. So 22.99, so 23 grams per mole. So we have half of that. So that's around 11.5 grams, roughly. Silicon's what, 28-ish? So half of that would be, we're around 14 grams. So that rules out sodium. And then uranium's huge. It's way down here. So we're at 1/4 of a mole, 0.25. So this one's going to be by far the largest. Because in this case, we would be multiplying by the grams per mole. And Miles, again, I apologize, your email, I understand now why you were thinking 50%, 50%, 25%. Initially, I didn't understand it in the email. And then looking back after I answered, I now understand what you were saying. On B, this is 9 grams, half a mole of antimony. Antimony is SB. So that's around so it's half a mole, and it's around 122 grams per mole. So this is going to be roughly 61. So again, it's just doing a rough estimate. And then for the arsenic, this number in atoms, that number is really small number of atoms, because Avogadro's number, the number for arsenic, this number would be 10 to the 23rd. So the antimony is going to be the most. You could always work it out. Sometimes writing it out on a piece of paper you can see how the ratios are going to work. So I would encourage you to go back and look at these and see if you can do it without having to necessarily solve the whole thing, but just thinking it through. On C is actually the easiest. If you have this many atoms of each one, the lead must be the greatest one, whichever one's the most massive. The other thing with this is just helping you hopefully to start learning your elements. Next week is naming. We're doing nomenclature, which is we're going to put the elements into compounds. And so if you're relying on your periodic table with the little names on them, it's going to make it a slower process. So if you start knowing your names that you know, okay, iron is Fe, tin is Sn, lead is Pb, that will help you. You don't need to know every single one. I would say at least the first 36. You don't have to have the order, but when I say iron, that you immediately go to Fe. You're not like trying to read little words. It makes a big difference. All right, let's go through the factor label. The first two questions also, I would say another thing besides being a really nice logic point is it's to remind you it's not just factor label that we're doing. In fact, next week we're going to be doing naming. There is a lecture Tuesday, but it's recorded, so it will show up on YouTube this weekend, and the notes that will go with it. So if you want to get a step ahead, but it walks through ions and cations and anions, and then lecture Thursday will go over that stuff. All right, but so the lecture is pre-recorded. For this, we're starting here with the 23.45, and MCG is just microgram. So you can write it either way. You just want to make sure people can read your handwriting, but it just means micrograms. And the question wants us to figure out how many molecules. So it's handy to see what we're doing. We're not going to have, we're just going, we have to get to grams to use the periodic table. So 1 microgram is 10 to the -6 grams. And again, with metric, you want to become pretty efficient with metric. I also want to mention, because we're in the second week, if you're going, holy moly, this class moves really fast. I've never had chemistry before. You could still switch to Chem 151. That would be something you would have to talk to me about today. You would have to email that teacher and see if you could. There's a way they do a switching. There might be something though, because it is a different number of credits, but that could still be a possibility in this week. But I do think you can all do this class. I've had most students been successful. You just have to make the dedication. All right, then we're going to go to moles. And the whole piece with moles is adding up these numbers, 18 carbons, 27 hydrogens, nitrogen, oxygen, and we get around 305. I ask that you use at least 4 sig figs with your periodic table, but if you want to go more, this last digit after the decimal from the periodic table, it probably varies for each of us a little bit. It depends on how we're rounding and how they rounded on the periodic table. But yeah, if you're having trouble getting that number, please do stay after. There is also a tutoring service in the library. I'm sorry, online through the library. And so if you have questions about that, you can ask me after. And then our last step is just the mole to 6.022 times 10 to the 23 molecules. So Avogadro's number is going to go with moles or molecules. The answer on this study set, I actually put them on there for you, so you had a place to check. Avogadro's number, we want to use it with 4 sig figs. The periodic table has 4 sig figs. The number we started with had 4 sig figs, so our answer has 4 sig figs. I put these there on the study set, so you had a place to check. Whenever I remember to do that, I will do that for you. All right, 1.2345. times 10 to the 18th. You can write it as the E like I did in these, or times 10 to the 18th. Make sure you put a unit with it. And then, Michael, this is like one of the ones on the worksheet that you had mistake that your first step is Avogadro's number, that you're going to divide by Avogadro's number to get to moles. And when I get to moles, you want to make sure you divide by that in parentheses. So when you punch it in, you have to get my exponent and pretty darn close to the number. I'm trying to get to nanograms. So I would then just do my 1 mole and I add up this whole compound, and 183.2, 183.19. Again, at least 4 sig figs. If you want to do 5 or 6, that's your preference. And then nano is, I do it trying to be consistent here. So I'm showing it this way with the chart, that nano is defined as 10 to the negative 9th. Now, like Mindy, the way you were saying when you were reading me your numbers, you do it 10 to the 9th nanograms per 1 gram, and you know how to do it that way, and that's great. So just be consistent the way you do it. And there's our answer is there. Any questions on the first page?
Do we have to show the steps of the compound of like every time?
You mean like how to get the 183?
Yeah, because
No, don't show that. Don't show me how you added that up. I did it on the problem the other day in class to show where it was coming from, because it was the first time we had done that. So I don't know if you guys understand Major's question. He's saying, do we have to show the 7 times 12.0, the 7 carb, like show all this work? No, just do it on your calculator. I will know if you got it right if that number is the same as mine or pretty darn close to mine.
okay.
So
I just
yeah.
had to do it for every time at the study set, and it just took a very long
Yeah.
time.
No, yeah, it does. It's tedious. It's a long time. And so no, please, I actually prefer that you don't.
Okay, thank
So
you.
thank you. That's all right. Our next one, 0.123 milligrams. And we're breaking it. This one we're going to break down to just hydrogen. So I like to see that because I know I'm going to have an extra step. So make sure you give yourself a lot of room. Again, if you're not able to print, just write it out on a piece of paper. You don't have to write my problem out, but you do need to show this in this factory label unit conversion formatting. So this is C10, H15, NO. And we have milligrams to grams. You can, again, do 1,000 milligrams to 1 gram, or 1 milli is 10 to the negative 3 grams. And now I add up my whole compound. I get around 165.23 grams to 1 mole. Now, this is the one, this problem, you want to label it more carefully because we're going to break it down to just the hydrogen. On the ones on the previous page, I didn't keep writing down my whole compound because I did not have this extra step. I've had students say, oh, do we have to? That's a lot of work. It's adding like 10 seconds to your time. And so do it mindfully and with love, and do it as a meditation. Right, on this one, since I started with the compound, I do 1 mole, C10. Definitely the mole to mole step has to show this. And then the hydrogen, there's 15 moles of hydrogen. And you only use the 15 once. If you start reusing numbers, you're just undoing your work. And then Avogadro's number of hydrogen. So again, this is our abbreviation. We want to write it as a capital N and a capital A, because if you write it as sodium, it's going to confuse the heck out of me. And there's our answer. Exponent 3 sig figs, because we started with 3. Again, I just keep going unless you have a question. We're going to milligrams of just the copper.
I do have a question. And the last part of the
Number
factor.
5?
Yes, where you put the Na. What calculation is that?
That's the Avogadro's number.
Yes, I understand it's Avogadro's number, but when we're calculating that part, what number do we use for that whole symbol
Here,
thing? Yes.
6.022.
So we use that.
Yeah.
Okay, yeah. So I understand that's 6.022 times 10 to the 23rd, but are we multiplying it by the hydrogen atoms?
This is just my unit.
Of hydrogen atoms. Okay, so
Yes. Yes.
okay, so
like
it's
grams is a unit.
right.
This is a unit. This is the number.
So the number that we're using is the 6.022 times 10 to the
Yeah.
23rd. Got it. Okay,
Yeah.
then. Thank
Yeah.
you.
Yeah, that's a really good question, Lisa. Thank you. All right, this one is quite a lot to write. You can, it is a hydrated compound, so write it as best you can. For things, when things have beautiful colors, the blues and the greens, it's actually in lab 3, I talk about it more. You include the mass of the 4 waters. Right, so milligram is 10 to the -3 grams. And when we add up the mass of all this, the copper, the 4 NH3s, right? The parentheses mean you multiply everything in the parentheses by 4. The sulfur, the 4 oxygens. This means and, meaning plus. So a lot of students are like, well, why is it saying multiply? Well, here we're adding all the different pieces together. You can think of it that way. So when you add it all up, you should get around 299.7. 299.6, we're in the same ballpark. So 299 point something, showing 4 sig figs. And this is the whole compound, the copper, NH3, blah, blah, blah. And then we do our mole to mole ratio because we want just the copper. That 1 mole of copper is 1 mole of this whole compound, blah, 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 blah. And then 1 mole of copper is 63.55. That's from the periodic table. And then 10 to the -3 grams is 1 milligram, and you should get my answer. Now, a quick comment, because Omar was going through this one with me earlier. He left out this step, this mole to mole step. You can get away with it on this one because it is a 1 mole to 1 mole ratio. However, if it was a problem where I'm grading it, like on the worksheet, you might lose a 1/4 of a point because you'd want to show that conversion. So the worksheet is a way for me to give you gentle feedback. So when we do the real thing in like 2 weeks, that you have more of the pattern. So the worksheets are tough. I mean, you guys are going through a lot, but this is so when we get to the celebration, the midterm, that it's like, oh, I've got this. I know how to do it. It's not like, wait, what? Everything was like a walk in the park, and then she slammed us with something. There is also another trick on this one, and I'm going to mention it in case somebody sees it. There's usually 1 or 2 students who see it. These 2 steps actually canceled each other, and it's because it went from milligrams to milligrams. So you can actually ignore them. So the 10 to the -3 is on top and then the bottom. I don't recommend you do that unless you're going, oh, I see it now. It happens actually again on number 8. But yeah. All right. Number 7, 381 kilograms. The nice thing about this was there was only one place to start so far for everything. And this is of the emerald. Emeralds are beautiful. They're these complex compounds. So you could write emerald or you could write the whole compound out. But it's beryllium. Beryllium is found in a lot of compounds or minerals. It's a silicated compound. Like I have a rose quartz that I wear, which is a silicate. Right. And the different elements that are mixed with it give you the different colors. So the beryllium is the beautiful green of emerald. I can't remember quartz, rose quartz at this moment. All right, kilogram to grams. And then we add up this whole compound. Now, this again was a question that came up during my office hours. You know, if you missed that, you're not going to get the whole thing marked wrong. The celebrations are going to be show your work. And so I'm looking to see that you can show your work. And so if you miss a piece, you would lose a point on a several point question because you didn't get the right answer. And I would circle which piece, like on the worksheets. I try to write comments to you guys on the worksheets. All right, this is of the emerald. And then for every 1 mole of the emerald, so you can write it as the compound, writing the whole compound out, you have 3 moles of beryllium. Emerald. And then for every 1 mole of beryllium, we are going to, so back to the question you'd asked, Lisa, you can write it Na, beryllium atoms, or you can write out 6.022 times 10 to the 23. Most students end up starting to write the Na as they become more and more comfortable with this. So this number, and if the other thing that can also help with your question, Lisa, and for all of you, you can also write the word atoms first and then the type of atoms after. So atoms beryllium or atoms B. It's kind of the beginning of a poem, it looks like. Right. And again, you can write the number or you can just write the symbol, but you do always want units with that number, even if you just write Na. All right. And then the last one. So you may or may not have noticed yet that the last question, the study sets, as you go through them, they get, the problems start building more difficulty. So number 8, we're going to be doing problems like this today. And so always try it. Try something, even if you break it on the study set into steps. And then make sure when I'm going through it, say, oh, I see how we do it now. Because that's part of what we're doing. It's a process of learning. So
I have a question on this last one.
okay.
So in the problem, you say what is the mass of cyanide in grams, but in the answer that you gave, you said it was 148 kilograms.
That's not a big deal.
Okay.
We'll deal with that. Was that Maddie?
Yeah.
Yeah. So it would be, oh, it comes out as a huge number of grams. So that's probably why I changed it to kilograms.
Okay.
I'll talk about that when I get to the end. Yeah. Sometimes it's a typo and I just, when I typed it up, the other comment I'll make for you, Maddie, I've never given the answers before. And because of the environment we're in, I was providing you with the answers. And so sometimes I do my answers in a shorthand and I type it there and I'm not looking at what I asked for in the question. So that's probably why. So kind of recognize, I guess I'm asking for some grace when I give you the answers. The other thing for all of you, my fingers are really clumsy. I'm sure all of you have made typos in your life. Sometimes I have typos. And so if you're doing it and you can't get my answer, you know, if you come to office hours and somebody lets me know, sometimes it is that. That's probably what it was here is because I gave you my answer and I have things sometimes different in mine. Thank you though, so I recognize that. I'll give the answer here in grams also. So if you did it in grams, but it's good practice to go to kilograms. All right. I recommend not writing it like what I just did because it's not actually just 1 kilogram. It's 1 kilogram of an ore, of a rock. Rocks are usually mixtures of lots of different compounds. Kobe could explain that much better than me because he's going into geology. So we have 1.00 kilograms of the ore. Kind of back to the question like Lisa had asked me earlier with this one up here, a lot of things will have 2 units with them. And I think that's actually now thinking about at least what you're asking. It's not just atoms, it's atoms of hydrogen. Like here, it's not just milligrams, it's milligrams of copper. And so here, it's not just kilograms, it's kilograms of the ore. We just leave out the word of. I have had a student in the past, more than one, who had to write the word of because that's just how their brain saw it. And that's not a big deal to me. It just takes up a lot of space. We're going to change the kilograms, go to grams. Most students at least will get that. Okay. we're getting good at metric, right? Much better than last Thursday, the first time we were working with it. And so just imagine where you'll be by next Thursday. You will all be ready to teach the class, right? So this is of the or. So our next step is this percent. And I didn't show you one of these before. So most people, when they do this problem, they don't show it this way, but then they pay attention to how I'm going to show you. To show the percent in the factor label, there's two ways you can do it. That you want units. That's the whole key with factor label. This is my recommendation for showing the percent is this. That what the percent means is for every 100 grams of the ore, you have 10.6 grams of the antimony. Percents are always out of 100. That is one way you can show it. The other way is 0.106 grams of antimony to 1 gram of the ore. So you're just getting rid of the 100, dividing by the 100 there. But that's how you would show it in unit conversions. I do recognize what a lot of people do is they take the 1 kilogram and they multiply by 10.6%, and then they'll say, okay, this is where I'm starting. But we're trying to show this all in the factor label format. So you're saying, okay, this is my starting point, and we're getting to here. And that one you could do mentally in your head because it was an easy. Antimony is what, 121.8 grams to 1 mole. You want to label. This one's easy to label, SB. And again, so SB is antimony. It is in the Bible. It's one of the most ancient elements. Somebody has it for theirs, which is really cool. It's always a fun. There's some really weird stuff. So we're going to do our mole to mole ratio. And I know I have a mistake there, but I wanted to point this out. The 1 is not on the bottom here. The 1 is with the compound. It is 2 moles of antimony. So just be careful. Here, the 1 was on the bottom because we started with the compound on numbers 5, 6, and 7. We started with the compound, so we had 1 mole of the compound on the bottom. Here, 1 mole of the compound, 1 mole of the emerald. But here, we're solving for the compound. So the 1 mole is on top of the compound, and the 2 moles is that subscript. Or here, the 3 moles of beryllium is that subscript here of the beryllium. And then 1 mole, whenever you use the periodic table, it is 1 mole. That 2 moles only shows up in the mole to mole step. Same with using Avogadro's number. And then the compound is 339.81 grams, ideally labeling it. And as Maddie said, I did ask you only to go to grams, and that's fine. So you would have gotten 148,000 grams, SB2, S3. Now, what I did, and as you become more proficient at metric, get rid of those 3 zeros and put a K, and it's kilograms. The other thing is this number is pretty big. You would want to show it in scientific notation, ideally. The zeros after are just trailing zeros. They're placeholders, so they're not significant. So this would be times 10 to the 5th grams, or 148 kilograms. Yeah. Questions? You can ponder that question, Maddie. That was actually a good question. So.
Sorry, I had a quick question. So on
Go
the
ahead.
bottom, I did the, like, I timed the SP by 2 right away. I forgot the step by mole.
Yeah.
So which came out the same, but I guess that
It does. It does. Yeah, I know what you're asking me, Major. So what Major's saying is here, he put this as 243.6 grams of antimony. What I'm trying to get you to do here is to be able, because we're going to get more complicated problems, and that way you're just showing your work. It's a more systematic way of doing it. And so this is showing me like the 121.8, okay, anybody can see, you know, as a teacher, okay, I see the 121.8 is right there. Where's the 2 coming from? Where'd you get that from? You know, that's what I would get from students. And so this is just separating it, showing me why you use the 2. And so
Okay.
I do want to see the mole to mole step. Like I said up here, the copper, I mean, this doesn't change it at all, but it does. It's showing me that you clearly understand there's only 1 copper in this compound. So it's just something in this format of factor label. It's not the only way to do stuff, but it's what we're working with right now as a way of showing our math. And when we get into chemical equations in like 3 more weeks, this will be how we're using the math. And there you're going to have to do the mole to mole step. And so this helps us to get there. So you can ponder that. It's a really good question. Anybody else have a question before I pause us and move into empirical formula? All right.